Welcome to the Tech20 at Net Zero Technology Centre. For those that I haven't met before, I'm Craig Nicholl. I head up the decommissioning and late life portfolio here at the centre, which this development and tech developer sits under. So I'm really excited to hear from Karl in the coming minutes. So we're delighted to have you all along the webinar today. Before we kick off, we've got a few housekeeping rules to go over. We call these events the Tech20 because we've split them up into 20-minute blocks. So first of all, we're going to hear from Karl for a 20 minutes presentation. We'll then have 20 minutes for really focused questions and answers. And then at the end, we've got a much more informal 20 minutes for networking between all participants and attendees. We've got two options for submitting questions. So you can use the Q&A function, or you can raise your hand virtually and we can answer it that way as well. So we want to make this sessions as engaging as possible for you and the speakers. So please raise your hand if you feel comfortable speaking, because it's good to get that dialogue going. We'll try our best to get through as many questions as possible during the 20 minutes after the presentation. But if you do, and finally, if you do comment on socials, please use the hashtags #Tech20 and or #TimeToTech20. Just allows us to share and repost as well. So let me introduce the speaker today. This morning we've got Karl Farrow of CeraPhi Energy. We have just recently approved a project supporting Karl. I won't steal Karl's thunder. I'm sure he'll go into that project in more detail throughout his presentation. But fantastically exciting space of the industry that we're looking at, and we can't wait to get going. Like I say, it's just recently been approved, but we can't wait to get going and working with CeraPhi to see what we can find within this study. So, Karl, are you ready to go?
I am, yes, thank you.
Perfect.
Intro and welcome everyone to this Tech20 session, and it's great to be have the privilege to be on this session with Craig and the Net Zero Technology Centre. So to kick us off, I think this will probably be a little bit of a different sort of subject matter in general to what a lot of people associate the Net Zero Technology Centre with, and certainly exciting for us. And you know, we're really keen to, you know, as Craig says, crack on with some of these projects which are coming around the corner now. So we, CeraPhi as a company, set up around June 2020. So we're just coming up sort of 2 years old now. We formally launched it September 2020. Basically a group of oil and gas sort of entrepreneurs, experts in various different areas, looking at how to get into some of the sort of renewable spaces, but also how to use, you know, what we already have and the knowledge, you know, extensive knowledge we have in the industry. And one of the areas personally I've been involved with back in 2016 whilst overseas in Mexico was a large geothermal project which was looking for some refinancing from a state government body, and it sort of blew me away at that time that, you know, why we haven't really done more of this around the world. And actually when I started digging into it, I found there was only, I think at the time, less than 14 gigawatts installed, which when you look at nowadays wind farms and that is pretty small globally, considering that geothermal started around 1914 in Italy. So what we really did is start to look at then, you know, why, and ask the questions why, when, you know, one of the things that is apparent in oil and gas is that every well we drill has heat, and the deeper you go, the hotter it gets, and in some places even shallow, it's really challenging and hot. And you know, heat generally plays a problem in our oil and gas developments from a processing and a drilling point of view. So we looked at building some sort of, you know, approach to combat that sort of challenge, and really focused on, you know, 3 key areas. First being, you know, how to remove some of the subsurface risk associated with drilling, specifically around you know, the challenges of trying not to drill where possible or trying to drill less. And secondly, really looking at how to maximize the efficiency of heat use. Everyone tends to look at electricity as being the sort of game changer to renewable energy. Well, actually, you know, 51% of actually what we use globally, or actually 75 in total, but 51% is used for heat. We actually use less than 20% for direct energy use, which is quite shocking when we always hear that we need more electricity to change the balance of renewable energy. And the third, really last one, was really delivery. So looking at how do we really, you know, change the dynamic in how geothermal projects are delivered and make them more plug and play, sort of oil and gas mentality. You know, short period of execution, engineering, construction, and delivery, rather than you know, most geothermal projects traditionally around the world are sort of 5 to 7 year type developments, or historically have been, which is pretty unacceptable from a point of view of energy development. So once we started looking at that area, it sort of brought us onto a key area. Well, you know, why don't we use some of the stuff we already have? We have wells drilled around the world, and actually they sit on the balance sheet of a lot of operators as liabilities. And how can we, you know, maybe use them wells to, you know, use the heat in place and actually help that process as part of the decarbonisation, but also at the same time look at, you know, deferring and helping to defer and avoid decommissioning of these assets moving forward to, you know, change of use, etc., or transition. And that took us through sort of 3 steps sort of into a different area, looking at, you know, reducing liability and sort of, should I say, exploration risk by having wells that are already drilled that could be used and transferred to a clean energy. It also then puts us in a space, well, you know, you can help remove the decommissioning risk and extend the life of these wells. But then I think the more challenging question and more sort of, should I say, in your face question is really, why can't we do this whilst we're actually producing, you know, at the front end of hydrocarbons, also use the heat to decarbonise. So there's sort of 3 different areas there, but we've mainly focused on at the moment on the obvious one, which is decarbonisation and you know, the access to decarbonised heat, which could then provide various benefits. And how we've done this is really taken a very simple approach using what we call a closed loop approach. You know, closed loop has been around for many years from a heat network point of view. It's been used in ground source heat pumps, it's been used in heating networks, and it's never really been used at this sort of scale, at this sort of depth and order of magnitude. So when we first started this, we started working with a ground source heat pump engineering business, and have sort of been side by side with them since we started developing this sort of technology. And we've developed effectively a very large ground source heat pump that can go to kilometers rather than meters and work with temperatures order of magnitude sort of suited to oil and gas than just the few degrees that generally work in a normal domestic environment. And what that does is enables us to, you know, talk in megawatts rather than kilowatts, and look at order of magnitude scale for a development. But what it also does is removes a lot of the inherent risks associated with conventional geothermal, like connectivity between drilling producer and production wells, or injection and production wells, where fracking is generally involved, and fracking is becoming more and more, should I say, a no-go area, specifically in Europe, and now in the UK. Obviously, we've had a monopoly against fracking, although there's certain discussion ongoing at the moment about sort of reactivating that. There is a big challenge to the fracking scenario, and if we can avoid that, or, you know, eliminate that, it actually reduces some of the environmental risks that associate that. So our system is a non-fracking approach. It's a single monobore system. It's an inlet and outlet in the same well, or multiple inlets and outlets if you have the right space. And the idea is to basically harvest the energy from the subsurface by injecting a working fluid into the well. And that working fluid then, as it gets deeper, conducts the heat, and then you send it back out of the well again to the surface. Most oil and gas wells today are drilled sort of between 2 to 4 kilometers. There are ones that are less, and are obviously ones that are more, but on average, a lot of the wells we've modelled and look at are sort of in that sort of range, specifically UK, US, and sort of the shale fracking area is very much that sort of depth. And at that depth, we are then talking global averages sort of up to starting around about 120 degrees at 30 degrees a kilometre. So once you start getting to 4 kilometres, you are in the starting point to be able to look at power generation. So most ORCs start to be optimized for electricity around sort of 120 degrees. And generally we are looking at ORCs in our sort of generation mix, of energy generation mix. And that applies to both repurposed and drilling new wells. So there are challenges and differences between the two. Obviously repurposing wells, we have to take well integrity into consideration and make sure that a well is first of all suitable for repurposing, meaning its integrity safe, and also that it has enough life in it to worth to validate spending any more money on to make it commercially usable. But when we talk about new drills, and obviously we are talking about drilling wells specifically designed to produce energy, and then wells are configured very differently to most oil and gas wells, as they most of the difference being in the size of the well. I mean, generally we would be drilling wells to a sort of 9 5/8 type diameter for our sort of approach, or even if we have a lot of shallow heat, even deeper or even wider than that. So really there are two different areas we are looking at. The low-hanging fruit at the moment is obviously repurposing wells, and a well is a well, so it doesn't matter whether it's an oil and gas well that was drilled, or it's a geothermal well that was drilled and it's failed, it hasn't been able to work because of various reasons. That well also can be used in our respect, or even water wells, things that have deep enough that have energy can be used. So any hole in the ground or well can effectively provide us with the energy. And effectively, our approach is to install a heat exchanger on the end of a pipe, or pipes into the well as deep as possible at the true vertical depth. And that heat exchanger then, as fluids flow through it, conducts the energy from the subsurface and enables that energy to be in place consistently for flowing working fluids through it, which generally aren't water. We generally use a mixture of various fluids that have a lower boil off than water. So the reaction of boil off is more of an aggressive energy production, and that then is obviously transferred to the surface to actually be able to work directly through other heat exchangers to increase temperature, or directly into a heat network or a ORC to produce some electricity, or a combination of all of them in many cases. So we look at the sort of energy center topside. Great thing about geothermal is a very small footprint. So we can have scenarios where you have multiple wells on a well pad connected to a very small energy center, and that energy center then can provide not only power but also heating and also cooling. A lot of us don't associate cooling with energy, but actually cooling is an energy, and actually cooling represents a huge energy source in a lot of economic economies which are developing, because a lot of them sit in the hot zones of the world where actually cooling has a bigger impact from a power pull than heating. So actually it's even in agriculture and lower temperatures, to get temperatures down cool so you can provide agricultural solutions in hot areas that are climatized, is something we're looking at. So the heat ranges, as I mentioned, we can work with temperatures from 30 degrees upwards. We tend to look at heat as the optimum energy and not at power. So we work towards achieving power, not from power and then down. Although if you do have hot temperature from power, then you can obviously model cascade to various different applications and offtakes. But the reason we work from lower temperatures upwards is because it's quite easy to boost temperature from 30 degrees upwards. So we can use sort of commercial heat pumps, which are off the shelf and available, which change through thermodynamics, use of heat exchangers, to be able to increase temperature. So if you've already got a temperature of around 30 degrees, it's quite easy to get that temperature up to a higher working temperature using working fluids. And like I said, you then work through a various cascade of approaches and uses for that offtake. So everything from low temperature agriculture through domestic heating, residential and commercial heating, to industrial processing, through to the higher side of energy from sort of 80, 90 degrees, where you get into water treatment, desalination, and then, you know, sort of luxury things like green hydrogen and stuff like that, which can be sort of then at the 120 degrees upwards when you're talking about power generation. So all these have a space in the energy mix. And see, one of the big inputs it has for oil and gas is by using existing oil and gas wells, we can actually not only help extend the life of these wells in an energy transition, but also use that energy for decarbonisation of the existing infrastructure and assets, or help to provide an ESG value proposition for these assets into the local community. So it could be for farming or for schools, hospitals, or other things to provide energy if you're in remote locations, etc. All of that adds ESG value to the operation. And the biggest thing going forward is obviously to be in a position where, like I said earlier, is to try and decarbonize the whole operation from the beginning. And this is where we start looking at co-production along with oil and gas production at the process. To make this work, we've developed a software system which is built around project execution, but actually builds in the front end part of actually modeling what a project is from the beginning. So basically just picking a site and saying, I need to deliver 10 or 15 megawatts of electricity with X amount of heating or cooling or whatever. We can do that from our system and plug that in and actually effectively spit out a project at the end of it, to explain what that is, what that's going to look like, and what the sort of financial models, bankability models and everything is of that project. And that can be done anywhere. So, you know, unlike conventional geothermal, where there has always been a sort of perception of you need to live in a area where you have a volcano or a geyser in your back garden to do it, that's not the case with our approach, because we are effectively able to drill to heat anywhere, and using the knowledge of oil and gas wells that are around the world already. We've already started mapping a lot of them and build them into our software system, and that software system is really developing now into the heart of what CeraPhi is going to be moving forward, which is effectively a project enabling company to be able to enable others to then go out and develop projects. So what we're actually doing is building software based platform, which will be a licensing model to pin energy generation to enable other people to then say, well, I want to develop a 10 or 15 megawatt project and I want to do it here, and they will be able to eventually plug in the information and actually generate the business case model to actually do it in the location they want. And the idea of that is to actually enable scalability in the geothermal space. We have big visions of what geothermal should be doing against what it is doing, and where oil and gas effectively can create that link with its track record and history and services and skills and people to actually move the whole industry into a transition in parallel with being able to keep hydrocarbons coming out of the ground in a cost-effective and environmentally friendly, carbon-free way. And again, this is sort of being built in a modular step and process. So, I think everyone realizes we're moving into a situation of microgrid energy solutions, or should be anyway. It makes more sense, it's more manageable and more scalable. And we've actually built our model around that. So anything from sort of half a thermal megawatt upwards to 20 megawatts electric is modelable and scalable on our platform. And the reason we started with half a megawatt thermal is because we're finding that an average well, certainly oil and gas well, is providing or able to provide around that type of energy source. So it really just sort of play into what oil and gas is already doing. And then at the side there, you can see the different areas which we can sort of impact on that process. So Craig mentioned support with the Net Zero Technology Centre. We've recently just launched a project through the Net Zero Technology Centre, looking at decarbonisation of a large offshore facility, one of the largest in the UK, from the perspective its size and also scale of the project. It's the EnQuest Magnus project, the former BP platform, which Petrofac are currently operating, and we're working with Petrofac alongside them in this study. The study's being led by CeraPhi, and the idea of it is to really look at how can we use existing wells in conjunction with produced water, which is also got heat and temperature and flow and volume, to actually look at moving forward to a decarbonised process moving forward. And the idea is to look at the study as how we can take chunks of the facility over time to actually reduce the carbon footprint as low as possible, using existing energy available for things that maybe heat and accommodation, cooling and accommodation, with a long process, etc., and how that can all be tied in to reduce the carbon footprint on the actual energy generation that's currently being done by gas, and also from fixed wire or fixed feed from the beach in some cases. One of the things we sort of really had a focus on now is more focusing on the ESG proposition, as well as just energy. I think we all look at energy as we have to decarbonize, but if we don't tackle some of the other issues that are around decarbonisation and actually facilitate the United Nations sustainable goals, it actually makes the challenge to decarbonise a lot more. It doesn't make it any easier, it makes it a lot more harder to actually achieve. So what we've actually started to link to is the key areas of recycling and reuse, with cost effectiveness, and bringing in food, water and energy into the same bit with transportation, and how can you create that sort of 360 model to actually remove a lot of these shall I say hurdles in the way through using energy as a focus point to do that. And it actually is quite amazing when you step back into that space of what the effect is and what the impact is. So we focus a large part of our business now to look at the ESG value proposition because of that reason, because it actually tells us how to actually provide the energy in a more sustainable way to tick the boxes and help all the other processes. And we will be launching part of this on our website very shortly, which will help companies actually model their ESG use through energy, and how they can actually impact the ESG sustainable goals by adopting the energy process that we're trying to develop through our CeraPhi Pro platform. So that's coming soon. Again, a lot of stuff going on in the background. I'll just move on to this is sort of really the last slide. When we set out on this journey, it was really came about a conversation I had with a large impact investor from Germany, the wife of who was one of the main drivers behind the Pfizer COVID vaccination. And over dinner, we were talking about how what would be the sort of the game changing impact change that we could possibly make given unlimited resource to funding, and what would be achievable. And we came up with some numbers really that we're looking at really, if we were to build a business that was focused just on enabling energy from geothermal, that business potentially could enable before the 2050 or by 2050 around 500 gigawatts of energy, which sounds order of magnitude when you think there's only 15 gigawatts today installed. But at 500 gigawatts is still only about 6% of global energy need at that time, given that as we are decarbonising, the world economy and the need of energy is growing at the same time. But what that actually equates to in real terms is around about 1,020 megawatt power plants over the next 28 years, and around about 100,000 wells either converted or drilled, which again sounds a lot. But when you think we drill anything between 40 to 50,000 wells in oil and gas every year anyway, or in a good year anyway, it's not a lot at all. And actually, this is all doable and achievable, and it will make a step change in the process moving forward. So it's really, we see this as really a way to make an impact change, using skills and expertise from oil and gas in a way that really helps oil and gas transition and get onto a net zero process, at the same time as making sure we also keep oil and gas alive and produce oil and gas, because we can't not do without oil and gas. We still need oil and gas in this energy transition. So we've built a really large team. We're now somewhat 25, 26, 27 people. We have representation in 2 offices in UK and in Houston. We have regional representation in the Middle East and West Africa and Brazil, and a growing and large advisory board of collective experts from different areas, from energy, but also from things like insurance, and we have from the MOD, and different backgrounds that give us insight into different areas, which again are really important for our development. And that's really it. So I hope I've hit the 20 minutes.
I'm scrambling for the start video and unmute, sorry. No, that's great. Thanks very much, Karl. I've been lucky enough to hear that similar presentation a few times, going through the communications that we've had with them, and each time I take something different from it. But the message that I get every time is, why haven't we started doing this before now? So, like I say, really excited that Net Zero Technology Centre can be part of this, and we're looking forward to really having a big push on the geothermal side. So there's just been one question come in so far, and it was asking the temperatures that we're going to get from the Magnus project specifically. And do you want to take that, Karl?
Yeah, absolutely. Well, the Magnus project, we're literally kicking off. We have had some provisional information from the facility which we've looked at. Generally offshore wells, in our experience, certainly the ones we've looked at tend to be a little bit hotter than some of the onshore wells. It's a bit hard to say what the temperature is going to be at the moment, but we certainly don't see any issue with looking at decarbonising some of the industrial processes that were going on there. Certainly things like water treatment, desalination, and all the sort of accommodation, cooling and heating and all the other stuff. And there are ways to boost temperatures. So even if we at the moment, I think we're probably looking at somewhere in the region of 90 to 100 degrees on EnQuest, and I think we'll end up probably being able to squeeze energy for electricity out of that by boosting that temperature further. But again, until we do the study, it's very hard to say. But we are expecting to get a combination of power and heat, smaller power, more heat. But it really does. It really will be a step change in, I think, the way we look at offshore installations, not just the ones that are there, but even future development now. And I think this is where we need to be very focused, and the study will provide us a lot of input. Is why not design wells and platforms nowadays that can not only just produce hydrocarbons, but also be seen as long life energy centers, which can then transition to produce clean energy, or produce clean energy as well. And I think this is where we should be heading, with all installations and energy facilities, whether they be onshore and offshore, moving forward. And I think that also gives the oil and gas companies a different energy transition perspective to look at, and also would facilitate projects being moving forward if they were aligning with green energy aspirations at the same time as production of essential energy like oil and gas.
Oh, excellent. And I think it is a consideration that needs to be done for any new installations as well, isn't it? So
for sure.
Yeah, absolutely. Good. We've had another one in from Marcus. On one hand, that you say the key is to go microgrid, and on the other hand, our goals are to declaring over 1,000 new plants and over 20 megawatts. How is this going to come together?
Yeah, so I mean, microgrid can mean anything from sort of, as we say, a few megawatts upwards. So The idea is really to be able to put energy where people need it, and not put energy, in the middle of a countryside and have a distributed network system, running all over the place, feeding energy when you need it to the people. We've seen problems in projects that are emanating in Africa, where large countries have gone in and funded geothermal projects in the middle of nowhere. And there's a lot of installed capacity now, but the capacity can't get to where they actually need the energy, and you now have lots of energy stranded and projects being effectively mothballed and turned off because they're not commercial and they're not being able to connect energy to the end users. So scaling energy actually where you need it is key. And that's the same principle as trying to do something like green hydrogen or hydrogen. You need to really try and use it where you produce it, because distribution of energy is not easy. It becomes harder as you start talking about heat, because heat has to be used very much effectively in the area you're actually producing it. So that's one of the reasons why we look at this modular package and modular approach, and it is very doable. So whether we enable 1,020 megawatts, or whether we enable 4,005 megawatts at the end of the day, is really down to the need of where we're looking at and how and where we're going to put these. The point we're trying to make on the slide is that it's doable, and that's what we feel comfortable is achievable as a company. And obviously, the more we get into this moving forward, the more scalable it becomes. And like I say, that when we roll out our licensing platform, we're then enabling others to sort of take the bull by the horns and do it using our platform and our process. And that's really what we want to try and do as quick as possible to make this happen.
And do you see that coming out? I mean, it answering itself, really, isn't it, with scale and demand? But because the availability for this technology to be deployed. Sorry, I'm kind of moving into an onshore more than offshore conversation here. But
I think one of the challenges is we forget, how much what heat use is in our daily life. And generally we most people just think about power as being, or electricity as being associated with energy. Well, actually, heat, as I mentioned earlier, is plays more than 50% in our energy use. And generally, if we try to go down the route of electrification of that, whether it be through solar, wind, or anything else, it's just a really negative way of using energy, because it costs us about 1.5 megawatts of electrical energy to produce 1 megawatt of heat equivalent. So it's not a good use of energy when we have other sources of energy that do use heat directly, like geothermal, or can produce heat like geothermal. If we were to apply that process to the energy mix and produce geothermal at scale and produce that usable heat directly, it would take a big strain off the production of electricity in the renewable space to be able to provide electricity where it's needed and get us to a net zero target a lot quicker.
Yeah, absolutely. So Marcus has come back with a counter. The energy where to your comment on energy where you need it. I could maybe take a first bit of this, but the offshore wells, how do you get the energy onshore? And what are the footprint considerations on a highly contested real estate on small platforms? So effectively, I mean, Karl, you're best to just go for this as well. I mean,
yeah, no, absolutely, and it's a really relevant. So with the offshore side, I think it's more about decarbonising the facility and decarbonising the operation itself, than really looking at how do we make money off selling heat and electricity from a platform as well. Although that obviously needs to be taken in consideration, and we don't see that as being the starting point. We see that as being where we're going potentially, but it's certainly not a starting point for the study we're looking to do with Enquest and Petrofac. But I think we are also looking at, and we have started already looking at projects where, well, if you can store energy like heat in salt caverns, and you can have a carrier medium that might be hydrogen, and you can take that to the beach and then separate it and then use the heat directly from that into networks and things like this, there's a really good opportunity to do that. And these are discussions we are having with a couple of other operators who are looking at CCUS and other types of hydrogen projects where, you know, if you have heat in the carrier process, it actually is a good way to actually move heat around with other things. You also need heat, and a huge amount of it in the CCUS process. And a lot of them are generated generally by heaters in the process, and even that is causing some problem in commercialization of CCUS because of the cost. And so, yeah, using the heat directly in that process to be able to keep the gas at a certain temperature, because it'll stop it freezing when it's being injected. You know, that itself can be a really good combination of using heat from offshore to transport onshore to then inject and then, you know, decarbonize and separate to use the heat for heat networks and the gas being injected into the ground, etc. So there's a whole bunch of things we can look at and that are looking at in this process, and we are really at the beginning of the road. I mean, we are literally stepping onto the road. I mean, this is, you know, although geothermal's been around for 100 years, it's actually, you know, dark ages we're stepping out of where we are, because it's very much been focused on you can only do this when you've got a geyser or you've got some sort of, you know, energy coming out of the ground, and we need to step back from that and come at it from an engineered approach, which is the way CeraPhi's doing this, and look at it as a science project. And geothermal has very much been looked at over the last 100 years as a science project, unfortunately. But we have the ability now to, you know, step into this with oil and gas expertise and knowledge and take it out of that into the next generation of baseload energy. And I think the baseload energy aspect of this is the key. This is not something that relies on the wind or relies on sun. This is something that's available 24/7 all the time. It has potentially 6 billion years worth of energy trapped under the core. You know, more energy than we can ever think of ever needing, and totally decarbonize what we have today.
Is that, and if that's not a sales pitch, a strong enough sales pitch, I don't know what would be, you know. So it's, you know, makes total sense that we investigate all the options with it. Vinny, I missed you, but I'm coming back to you. The conventional organic Rankine cycle has limitations, as we know, but how can your technology overcome and/or compete with other geothermal technologies?
Yeah, so the way we use an organic Rankine cycle is it's not like we just use one and it's going to be, you know, and try and make that work. So the idea is to bundle these systems and have multiple systems running, so you create a baseload energy from that process. Yeah, totally get it that Rankine cycles do have limitations, but when you look at large-scale geothermal projects, they also have multiple limitations, specifically in you know, in optimization use over time, scaling of systems, and all sorts of stuff like that, which restrict and reduce energy capacity, and also you've got the initial cost of upfront cost with the conventional geothermal of actually finding that right resource in the first place, which has a huge exploration risk. Whereas if you're just drilling down to heat and you actually, you know the heat's going to be there, and you're fitting a system in which is manageable, controllable, and engineerable, you know, we can work through these efficiencies going forward and make them more efficient. We are working on a project with Brunel at the moment, looking at increasing the bandwidth of organic Rankine cycle efficiency. Currently starts at around about 80 degrees to start generating electricity, 120 to start getting some form of base load, 150 to get sort of more optimum. We're starting to try and look at that now. How do you get that down even lower threshold, maybe to 60 degrees? A lot of it's going to be in being clever with chemistry and working fluids, as opposed to the dynamics of really just the organic Rankine cycle systems. It's another area that really hasn't had a lot of attention over recent years and development, and we have spoken to a lot of manufacturers trying to see if we can work with them to help increase the efficiency of these systems. A lot of them aren't really interested. They say, no, we're building this, it's work, we're selling them, we know, why would we change? And I think that's generally how a lot of manufacturers sit in most industries. So we've got to, you know, we've got to test these areas, we've got to push the boundaries, we've got to push some of the limitations on these to make it more doable and more achievable.
Excellent, thanks. Now, I'm conscious of time, but Al, you've come with one more question. I had a few questions, but we could maybe come to them with the networking if people want to stay back and open the floor up. But I'm worried that this isn't an easy answer. But how long on average does it take to bring a repurposed well online and produce energy compared to a new well? And finally, on that, what's the current bottlenecks and constraints surrounding that question as well?
Well, I think I'll start with the bottlenecks and constraints first, because they are the important. So well integrity is critical. We have to ensure that, first of all, the well is a safe well to use, that it's got no integrity issues. So we would do all the normal things that you would have to do that. The well would then go into effectively an abandonment stage, or at least be started in an abandonment stage to basically isolate the reservoir from the well. And then we would start looking at converting the well from the lowest TDV. And at that point, you can only work with the energy you've got. So, we are constrained when we repurpose wells to what the TVD is. And, that is a stop point really of going any further, and that really is, you don't really gain anything. So multilaterals and these deviated wells or highly deviated wells, although they might have a longer depth, we might consider using them for more residence time, for having liquid in place a bit longer. So there are things like that, but generally, the true vertical depth is where you would go. But actually the time scale of doing these is relatively quick. Once you've done the sort of assessments to say, well, we can get this much energy after modeling, design the system and install the system on the site, specifically onshore, is not a major challenge, and offshore would be, effectively a small piece of kit, generally per well, or a larger piece of kit for multiple wells. But yeah, just designing a system and getting it installed would probably be, at the moment, we're looking at sort of 6 to 9 months, maximum 12, to do sort of well retrofits on a site onshore. So, offshore would probably be not much longer than that, subject to obviously getting the right space to install equipment. Offshore is still a little bit more challenging for us to understand at the moment, because of, we have only just sort of starting this study with Enquest and Petrovac, and I think, hopefully a sort of 6 months down the line, we'll be in a lot clearer position, and hopefully that report will be in somewhat shared, or certainly certain details that we can will be shared with the general community. I think that's the plan, and hopefully that will stimulate a lot of other Q&As and answers that we can learn from, or try and move forward to look at.
Definitely. No, thanks for that. Marcus has actually come back as well. I'm very conscious that we normally move on to open it up to some networking, so we can have some just two-way chat. So Marcus, I welcome some more conversation. If you'd like to stay back as one of the participants of the networking, we can explore some more specifics. So are we okay to do that? If anyone wants to stay back now, we'll open the floor to some networking. And by magic, it should work.
Hi, Craig. It's Gary here.
Hi, Gary.
Hi. Just thought I'd sort of jump in. I'm one of Karl's partners in CeraPhi Energy, and just sort of pick up on the last question, Karl, that you answered there about the time scale. Mm-hmm. There's a time scale in actually converting the well, but the wider time scale is the point from which you identify a well that you may want to use, the time it takes to then negotiate the potential use of that well with the client. And this is where I think the subject of this the subject matter of today, liabilities into assets, the conversation we have early stage with the operator of a well which is not producing, And when we explain how we can turn that liability into an asset, becoming a geothermal well, that's a fairly quick conversation. That doesn't take a protracted length of time to have them get that light bulb moment where they see the benefits of what this could bring to them as an organization in decommissioning, deferral, etc. From that point, we then need to move into a fairly deep feasibility study where we look at the well integrity, we look at the location, we look at the environmental impacts, but we also, more importantly, look at where we can use the energy that we anticipate getting, who will be the users. So that process is probably about a 6-month process to get to the point where we've got a bankable proposition and hopefully energy partners aligned, so that once we produce, we have the takeoff of there. So it's a fairly quick process. We could be at the point of well execution, well intervention within about 6 months. And within 6 months from there, we could be at the point where we've got energy for sale. What we need is to get those clients lined up to do that. And this, to some extent, is where we need government intervention. Whereas 20 years ago, government intervened with offshore oil, with offshore wind, and gave a guarantee that if you produced electricity, we would buy it and we'll give you a price that you can base your project on.
Yeah.
At this moment in time, geothermal is standing alone in this particular campaign, that we have to find a client and we have to then create that risk removing factor in order to allow us to get the investment and develop the project.
Yeah.
Some government intervention at this stage is what we need to get more of these off the ground, because once we have more of these off the ground, like wind, they will become self-funding, self-financing, and they will achieve what wind has achieved, and it will need the intervention at that stage. That's just my little spiel.
No, it's good. No, thanks. And Marcus, I noticed you've joined for some networking, which is great. Thanks. There's something a little bit more focused on. I don't know if you want to. You can unmute now and have a conversation with us, or I can just look it back up again. Your counter. Yeah, it was around the specific heat exchanger bottom hole assembly. Do you need insulated pipe for that to close the loop when operating in a single wellbore?
I mean, we've looked at all the different options of these types of things. I mean, we have wide intervention and wells, capacity of the company and expertise. One of the things you have to look at is cost, and actually, a lot of although insulated pipe is a good idea and it will help. It's really, from a cost point of view, it doesn't really add massive value. Unless you're talking about multiple systems where you're trying to get a lot of power, which is a higher cell value, and you're trying to obviously connect the sort of higher entity energy to power. It's not really going to, it's certainly from a heat network point of view, we've found it's really doesn't add any massive value if you're only talking about trying to keep temperature at 50, 60, 70, 80 degrees. When you get to higher temperatures, that maybe 150, where you're trying to go for electricity, which is a higher cell value, it then sort of comes into more of an economical play. And the idea is, I mean, we have to also remember that the space we're in, although we are connected with oil and gas in this, and we are looking at transition and oil and gas expertise and knowledge, it's not an oil and gas ROI, it's a utility ROI. Yeah. So you have to, and that's quite shocking when you get a lot of operators then look at is that it? Is that all you're going to make? But what you have to then think out, we're going to be doing it for maybe 25, 30 years under a power purchase or a heat purchase agreement. It's not a 5 or 6 year payback. It's a long game. And, so yeah, it takes a little bit of a different mindset from the oil and gas space. A lot, as Gary mentioned, a lot of this is about understanding and knowledge transfer and people's perception and everything else on the line and that. And I'd say 50% of the journey we're on as a company is education and teaching people and telling people and explaining to people, you know, how this works, what it can do, and all that. And there is this transition side which people need to understand, that if you're looking at this as a way to make, you know, oil and gas money, it's not the business case you should be looking at. If you're looking at this to, you know, help facilitate an energy transition, help ESG value proposition, help decarbonize, and that, yeah, it's a huge value proposition. So I think, yeah, it's really just getting to people's mindsets and some people get it. You know, we have the argument with some operators that yes, we can help defer decommissioning costs. Others will come back and say, but the cost is always there. And you go, well, it is, but you're already 2/3 of the way into the cost by doing this. So it's not all there, only a bit of it's there. And actually, if you get it right, you can hopefully, moving forward, transition away from being an oil and gas well to being a clean energy well, which then means you totally remove the liability from a balance sheet as an oil and gas operator. And also, you know, if I was to go out and drill a 3-kilometre well, there's more risk in drilling a 3-kilometre well than taking on the liability of a 3-kilometre well that's already there. So providing it's integrity safe. So, you know, it depends really which side of the fence you are and where you sit and how you look at it. But, you know, as far as I see and we see, there's only upside in this. Just there's, you know, the upside is far more greater than the downside.
Yeah.
I see Darla's got a hand up.
Yes. Well, good morning, everyone. I'm already sold on geothermal energy and your approach, so no need to convince me further. I would like to find out more about what you guys need in order to get moving faster from a funding standpoint, as well as connections that need to be made from the private sector. Basically, I know that everyone wants more government intervention and funding, but in the event that's not happening quickly enough, my interest is to get geothermal energy on the map within the next 3 years.
Yep.
And actually get customers for companies like yours and investment opportunities.
Yep.
To actually make progress in deployment. So I'm really interested in hearing what your current state of helping lead the energy transition might be.
Yeah, so that's really good question, actually. And on two fronts, I mean, I'll talk about company front at the moment. We are going for a Series A round. We are raising capital specifically to scale go-to-market. So we are looking at a technology, we call it a test demonstrator. It's not really a test demonstrator. It will really be somewhere we can test, build, and deliver our CeraPhiWells moving forward that can then be sort of effectively performance guaranteed and underwritten to go to market. So we can build a well in a facility that then has a performance guarantee, a bit like, you know, Siemens or anyone would build a turbine, get it bench tested and then send it. We want to be able to do the same with our CeraPhiWells, because then we can underwrite performance, delivery, equipment warranty, and have it all ticked off before it even goes to site. I think secondly, you know, we are moving into projects now. We've already secured some capital for some projects we're actually moving into, well site conversions. These are now stacking up in the background. So, you know, where we had one or two, you know, yesterday, we've got 5 or 6 tomorrow. And, you know, as we start moving forward, that 5 or 6 will quite quickly grow to 10, 12, as Gary mentioned, getting people, resources, and ability to go out and scale up is for growth, is go to market is quite you know, quite an important part of it. You know, you know, having had businesses before, having grown businesses, one of the growth issues you do have is actually you can grow too quickly. And you actually have opportunity and no access, or should I say limited access to resource and cash flow to be able to scale. That's always a danger, as in any business. And, you know, we're managing that quite well at the moment, but it's something we are always looking for support and help on. I'd personally like to see a lot more traction and movement with oil and gas operators actually supporting that delivery side. You know, we don't have to go out and spend years in R&D. We're not an R&D development company. We are an execution delivery company with some technology which is ready to go to market. And we'd like to see a little bit more, should I say, push by oil and gas operators, you know, like the Petrofax, Enquest, and other people who are standing beside us, Halliburton's, etc., who are jumping in the ring with us and saying, you know, we're going to take a punt on this. This is really where we want to be. And also the next, you know, Zero Technology Centre has played a huge role with us in the last, you know, 12 months in discussions, specifically Craig personally with his ambition and passion for the geothermal space as well. So yeah, I think you know, we are a small minority of people that believe in it, and I think that small minority is growing, but it is more of a movement and a mission. You know, there's a lot of passion behind this, and we will get there. And I think yeah, we just need to, I think, you know, I'd like to see a lot more, you know, companies throwing the towel in the ring with actually giving opportunity, access to wells, access to, you know, facilities to actually, and access to some cash flow to actually move and do these projects, you know.
Yeah, I could just add to that. Nice to have it. Not to make it sound like a cult, but it's nice to have another believer on the call. Nice to meet. But
definitely a pleasure. I'm tuning in this morning. It's actually 5 o'clock here from the United States in Colorado. We have about 100,000 wells, many of which are just covered over. And people build houses on them to the detriment of those houses. But those I see as huge opportunities for growth in geothermal.
Yeah. I mean, we currently are working with several major operators in the US, looking at Oklahoma, Wyoming, you know, Texas, obviously. But as Gary mentioned, you know, one of the big challenges is you know, there is a process. So there's a, you know, 3 to 6 month lead in discussion, and then you get to studies, and then you get, and you know, I think the problem is as you get to the execution stage, and then everyone wants one, and
yes,
and you know, and it becomes that becomes a scalable issue.
Yes,
is like whenever
that's mostly what we do. We're more of an R&D company as well, but we have many connections to places that can execute. And yeah, we just need, we're organizing cash flow to the places that are needing it. So yeah, I'd be happy to talk more later.
Yeah, I think the good thing is, just to sort of add to that, is that, you know, we have got strong partners. We aren't a drill and execution contractor. We aren't a workover contractor. We're not an EPC contractor. So we have the partnerships with the companies that do all that, and are building them partnerships. And you know, what we really want to do is bring the know-how and technology delivery side to the table, to then work with multiple partners globally to actually then scale up and deliver.
Excellent. Thank you. It's always a pleasure to meet companies that are guiding the way. So really appreciate your answers.
Excellent.
Karl, I have just sent you a little note with my email address, so we can hopefully connect after the event.
Oh yes, definitely. Gary Williams at CeraPhi.com. Yes, and I'm with Deep Science, so I will I'll reply back to you with my email.
Thanks very much, Don. Been great to touch base with you. Karl and I are often over in the US. We have an office in Houston, so we could very much follow this up on a more local basis.
Excellent.
Excellent, thanks. Well, that's perfect timing to bring this to a close. But I can actually say, I never said in the outset, this is my first Tech20 that I've hosted, and it has gone really well. I found it really energizing to be part of. Thanks to Karl, Gary, and all the participants. It's been a pleasure, and we please keep in touch throughout this study. We really want to show off what we're finding throughout this study, and we'll make sure that we have big communications towards the end of it with results. So thanks again. Enjoy the rest of your day and have a lovely weekend.